Okay. So, taking a look at this, wants to know, is 5 over 2 a solution to the inequality? Okay, well here's what we're going to do. First, I want you to solve this. So that becomes a 3x. That becomes a minus 21. And we still have 5x minus 4. So I'm going to subtract the 3x to get all my x's on the same side because it's a positive 3x. So that's gone. So now I have a 2x minus 4 less than or equal to negative 21. So I add 4 to both sides. And by doing that, that's gone. So I'm getting 2x is less than or equal to negative 17. I divide both sides by 2. And I get x is less than or equal to negative 17 over 2. Well, to figure out a little more exact of what that is, that's like saying 8.5. So x is less than or equal to negative 8.5. So anything, basically what this is saying is anything that is less than negative 8.5, like negative 10, negative 30, negative 100, is correct. Anything that is less follows. This right here, this isn't even negative. Because it's not even negative, that isn't even a solution. So the answer here is no. 5 over 2 is not a solution because 5 over 2 is not less than that. 5 over 2 is like saying 2.5. Is 2.5 less than negative 8.5? No, of course not. So that is not a solution. Alright, take a look over here. With these, I like to call them sandwich problems because you have the x in the middle and the two items on the outside. With a sandwich problem, you have to make sure that you do something to every side. So to get x by itself, I need to subtract a 15. That means I need to subtract a 15 here, and I need to subtract a 15 here. So that's gone. Negative 15 and negative 15 is negative 30, less than or equal to negative 3x, which is less than or equal to 9 minus 15 is negative 6. Okay, no problem. This is negative 3 times x. So I'm going to divide by negative 3, which means I need to divide this by negative 3, and I need to divide this by negative 3. Everything. Negative 3 divided by negative 3 is 10. Negative 6 divided by negative 3 is 2. I have an x in the center, but what did I tell you before? Whenever you divide by a negative, you flip the sign, which means I flip the sign. But I divided both, which means I flip the sign everywhere. Whenever you write a sandwich problem, it needs to go in order from least to greatest. I have 10 and then a 2. That's not going in order. So just like before in the last problem I was talking about, you need to flip that whole thing over, which means the 2 goes here and the 10 goes here. The x is still in the middle. But what happens when you flip those inequality signs? Right? A greater than becomes a less than. So really, it goes in this order right here. And when you go and graph something like a sandwich problem like that, sandwich problems mean you kind of graph them right in the middle. If this was a 2 and this was a 10, right, because they are both less than or equal to signs, I put a little dot there and it's closed in. But a sandwich problem means you shade in between the 2 points is how you shade. So with this problem right here, I would add 6, but I need to add it everywhere to all the sides. So as a negative 3, still have a 3x on the inside, still have a 12. 3 times x, I divide both sides by 3. Negative 3 divided by 3 is negative 1. That's an x, and that's a 4. So once again, that's a sandwich problem, which means if I had a negative 1 here and a 4 here, closed hole, right? Because they're less than or equal to's. And a sandwich problem means you shade in between. And last but not least, minus 6 here on both sides. So when we do that, I get negative 18. That's gone, so I have a 3x. And I got a 6. 3 times x, so I divide by 3 on both sides here. Negative 18 divided by 3 is negative 6. That's an x. And that's a 2. So, once again, just like the sandwich problems, if that's a negative 6 and that's a 2, it's a closed hole and a closed hole, because those are less than or equal to, and sandwich problems mean you shade in between. Alright. So the keys here is whenever you multiply or divide by a negative, you need to flip the sign. That's a key. Also, when you're doing these problems, remember, if I gave you something like this, right, and the variable needs to go over, I flip the entire thing over, which means that sign needs to flip around. And when you flip a sign, right, when you flip that sign from less than, it goes greater than, or if I gave you a problem that looked like this, it would then be flipped. If you follow me, you got to flip that sign around whenever you're flipping them. But if you have any other further questions or concerns, please feel free to let me know.